The factoring pattern that we're going to look at today is x squared plus bx plus c, where c is negative. Some of you were already asking me this, trying to anticipate what would happen if I had a problem that looked like x squared plus 2x minus 24. We've already studied what happens when this sign is positive. We know that that tells us the signs are the same. So I think most of you can deduce that the signs are going to be different. Before we actually factor this particular trinomial, let's look at some trinomials where the signs are different. Let's say x plus 3 times x minus 6. When I FOIL this, I find that it's x squared, negative 6x plus 3x. Actually, let's write that down. We've got 3x. Here, I want to make room for this on the other way. Let's start over. So, what I've got here is x squared. This gives me positive 3x, and this gives me negative 6x. When I combine these like terms, I have unlike signs, so I'm actually subtracting. It gives me negative 3x. And then when I multiply the last, it gives me negative 18. We can see the reason that c, or the number that is in this position here, is negative, is because these signs are different. When I multiply different signs, I get a negative. So we are absolutely correct in assuming that when c is negative, it means the signs are different. We're also, obviously, we're getting 18 by multiplying 6 and 3. So we're looking for numbers that multiply to 18. But this time, what's the relationship between the two factors? The two constants, negative 6 and positive 3. Well, you can see that when we combined them, because they're unlike signs, we actually subtracted. So in this particular pattern, I'm looking for numbers that multiply to 18 and subtract to 3. The one last tricky thing is what sign goes here, but let's hold on to that and see what we can do with the x squared plus 2x plus 24 as we try to devise that. I already know that when c is negative, it means my signs are going to be different. Let's put in our variables. Now, I know that I'm looking for numbers that multiply to 24 and subtract to 2. And clearly those are 6 and 4, because 6 minus 4 is 2. But with unlike signs subtract, I know that I'm going to use the sign of the greater. So the bigger number is what goes with this sign. Let me show you here. I'm going to put that in, and we're going to do a little bit more. I know that the 6 has to go with the positive, because when I do the outer and the inner, positive 6 and negative 4, when I do unlike signs, I subtract and I use the sign of the greater. So the bigger number must have been there. Let's try another one. Let's do x squared minus 4xy plus 12y squared. Okay, just like with the other factoring patterns, I'm going to draw my parentheses. Notice I have variables here and here, so when I put in my variables, just like when we did the other patterns, I need an x there, and I need y's in these positions. Oh, wait a second. I put the wrong sign. That's not what we're factoring. We're factoring this. So, I know because this sign is negative, my signs are going to be different. I'm looking for numbers that multiply to 12 and subtract to 4. So, if you can't think of that right off the bat, you can just say, okay, 1 times 12. 12 minus 1 isn't 4. 2 times 6, well, 6 minus 2 is 4, so I've got my numbers. When I do the outer and the inner here, I know that they're going to combine. We're going to do unlike signs, subtract, use the sign of the greater. So that means my bigger number, 6, has to go with whatever sign is there, which in this problem is negative. And my other number goes here. So let's just check if the outer and the inner work. The outer gives us negative 6xy. The inner gives us positive 2xy. When I combine them, I get negative 4xy, and that is what I'm looking for. Let's do one that only has one variable, but tends to confuse kids. X squared, let's do plus x minus 20. Okay, so I know that I'm going to put in my variables. This sign tells me that the signs are going to be different. And I'm looking for numbers that multiply to 20 and subtract to what? Well, we all know that when there is no coefficient, the coefficient is 1. So what does it mean when numbers subtract to equal 1? If you think about it, that means they must be consecutive, because let's say 8 minus 7 is 1. 9 minus 8 is 1. In this case, the consecutive numbers that subtract to 1 are 5 and 4. They multiply to 20 and subtract to 1. 5 minus 4 is 1. And because this turned out positive, that means that the 5, the greater, needs to be positive, and the smaller needs to be negative. When I check this, I've got positive 5x and negative 4x, and they do indeed equal positive 1. So let's just summarize. When we're doing this factoring pattern, again, we want to draw the parentheses. And put in the signs. If C is negative, that means they're different. Then you want to put in your variables. I'm not going to explain that because I'm pretty sure that's obvious to you. Here's where it's tricky. We're looking for numbers. The numbers whose product is C, and sum, it's really the sum again, but unlike signs subtract, so you're really subtracting, is B. And the greater number, the bigger number, goes with the sign of B. So we're going to move on and do some more complicated kinds of problems. These are the ones that always mix kids up once we get going. Actually, let's just do one more that looks like this. M squared plus 7m minus 15. So I'm going to draw my parentheses. I'm going to put in my variables and my signs. And now I'm looking for numbers that multiply to 15 and subtract to positive 7 or subtract to 7. So I can't think of anything right off the top of my head. Just to make sure, I'm going to say 15 and 1. Well, 15 minus 1 is 14. I'm going to say 3 and 5. Well, 5 minus 3 is 2. In fact, those are all the factors, and since that doesn't work, this is prime. There are some that you have to do more steps to, but we're going to save those for a later date.